Well, now let's turn to another one. And this one has been exciting for me. This is how to do CAD drawings. And Earl Hackett is doing a fantastic job, and we're getting an awful lot of people viewing this segment on the shows. So, Earl, I will turn it over to you for how to do CAD drawings.
Okay, let's get this screen share up here. Share. And I'm going to start with my little PowerPoint. There we go. This is the third installation. And what we're going to do here, we're going to construct the bridge, half of the bridge. So we're going to build the floor beams, stringers, and knee braces. And we take that thing and mirror it, and you have a whole bridge right there. We're going with the half bridge because it gives you more visibility. You can see what's going on. You can position things better than if you try to build the whole thing full width and then move the girder. That would just be a bit of a nightmare. So if you have any questions, again, here's the place where you can contact me, ntbridge924@gmail. And I can take a look at your work and see what kind of problems you're having. These are the parts. The floor beam is the larger one. It goes from side to side. The stringer runs the length of the bridge and ties all the floor beams together. And the knee brace is a piece that looks sort of like this, and they go on top of the with the floor beams and help stiffen it and connect it to the girder. You're going to want to have these dimensions handy when you do it, and this one here. This is the final width of the thing. This gives you, I'm going to call this 13.2. It makes the math a lot easier to deal with. And, well, let's get on to it. We'll bring up, escape from this. I'll bring up, now, you probably want to take some screenshots of these. So I'm going to go back through them slowly so you can get some screenshots. Because these dimensions are really important to know. Okay. Let's get this guy up. And we'll go to Onshape. And I will sign in. Okay. As you can see, I have this one here. I practice before I do the show. I work on, that's what we're going to wind up with at the end of the day. Now, I gave you some homework to put a cover plate on the end here. And I haven't done it on this one. I did it on the practice one. But I'll put that on later. We're going to get started with the stringers and the beams. So we're going to go to look at it from the front. And we'll do it from the front. Okay, we're going to start by building the gotta get this up on here on my other screen so I can see it. Start with the knee brace. And pick up sketch. We're going to do it on the front plane. And we're going to do a line. This one here, we're going to actually have to sketch the darn thing. So we're going to start with just now notice I'm keeping that one horizontal. This one here doesn't make much difference. This one has to be horizontal. And then we're going to connect them. Now, This one here probably is not horizontal, so I'm going to, okay, so now that put a constraint on that as being horizontal. Now we're going to dimension them. We have dimensions for this one, this one, and this one. This one here, it's whatever it happens to be. So we're going to take our dimension tool, start with this one here. That is 7 millimeters. And then we'll go to this one here, which is 8.25. And this one is 1.8. All right, and that's whatever it is. And we'll say, give that a check. And we're going to extrude this. And I'm going to extrude this to be fairly thick. I'm going to extrude it to 0.4 of a millimeter. Because this really is a structural piece, and this isn't steel. This is just plastic. So let's just check on it. That looks good. Go back to the front. Now, on a prototype, you would have reinforcing angles on all three sides here, as well as the top. I'm just going to put them on a couple sides because I'm never going to use this as a model. It's for an instructional video. So let's start with this one over here. We're going to use a tool that I haven't used before. We're going to sketch on this surface here, and we're going to use what they call an aligned rectangle. And this will create a rectangle whatever angle you want. So we're going to start with this corner. We're going to come up, and I'm not going to go to that corner because if I do, it'll define that point. I don't want that defined yet, as you'll see in a minute. We'll go to here, and then we come down to here. Now this is, that's 1. Okay, so now we can define some things. Measurement, this guy here, that's just 1 millimeter. Okay, now, this reinforcing angle, it's got to be trimmed to meet all the angles that we're dealing with here. So what we're going to do, we have here trim and extend. We're going to use that in a minute. But right now we're going to extend some lines so that they go as far as we need. We're going to actually extend them longer than we want. So we're going to extend this one, and we're going to extend this one. Okay, now we're going to take a line. We're going to go from this point to, well, just keep it parallel. Escape line. And we're going to go from, better make sure I get this right, line from here to there. And escape line. So now comes the trim little thing. And you could run into trouble with this. Where'd it go? Here he is, trim. What it will do, it'll trim a line to wherever the next intersection is. So you trim that, this, 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 and this. And now we just say, okay, we're happy with that. I'm just going to fix it. So now we have our odd-shaped rectangle here. So we're going to check off on that, and we'll go again to extrude this, and to keep the numbers. And oh, look at this. It says add. You do not want that. You want a new one. And watch. See if it. 0.2. Okay, still new. Okay, the little stinker keeps trying to plug it in there for me. Okay, we're going to do it. Going to do it again. And this is these are 3 by 4 inch angles that they use. So I made this one 0.2. The actually the 4-inch length would be 1.2 in HO scale, or pretty darn close to that. So we're going to make another one, just the same thing we do with this, only much thinner. So we're going to do a sketch. We're going to sketch on this surface. And we're going to do another aligned rectangle, exact same deal. To there and down here. Okay. Zoom in so we can get a close look at it. The only dimension we have to worry about is this one here, which is 0.25. Just to make it strong enough so it can survive. And we're going to do the extend thing again. This one. Yep, this one. And we're going to draw lines. Come on, there it is, escape line. And then down here, another line. Escape line, okay. Now we get our trim little scissors out here. We're going to put the flange on this guy here. So we're going to go back to a sketch. We're going to sketch on this surface here. And we'll again do the aligned rectangle. And we just set up this one measurement. That's 0.25. Never had a power failure like that before. So we want to go to extend to right here. And then we do a couple lines. Escape line. Oops. Phooey. Front. Push the wrong button. Line from here to about maybe there. Escape line. Trim. And we're going to trim this guy's up. And you got to find here he is. Trim. That. This. This. This, and this. We're just going to lock it in wherever it is. He's there. Check. Then we're going to do an extrude. That. New. Don't forget that. And we're going to go 1 millimeter. That gives us a 1.2 millimeter width on the flange, which is about 4 inches. Take a look. That looks good. Check. Okay. Now we need the flange on the other side here. So we're going to take part 3. That's the one we want. I'm going to translate it. Liner points from there to there. Copy. Check. And then we're going to take part 4. And we're going to translate that one over there. Translate. Liner points. There to there. Copy. Check. All right. That looks good. Front. And we just make them all into one piece. I like to keep the parts count minimal. And we'll do it. We can do another one down here. This is more less complicated. Where are we here? sketch this surface here, plane rectangle, and I'll run it from there to, it's going to be about there. That's a nice number. Okay. And dimension 1. Check. Extrude. New. 0.2. Check. See if it looks good. That looks good. Front. And we'll do another sketch on here. Rectangle from there to there. Dimension, let's see, 0.25. Check. Extrude this 1. New. Check. Now I go around here. We're going to do the same thing again. Part 3. Translate liner points there to here. Copy. Check. Part 4. Translate liner points here to here. Copy part. Okay, check. I'll go to the front. And we'll make this into a single piece again. Check. Okay, now we're going to do the floor beams. Go to the right side. Put one up and around in here somewhere. Now the floor beams, bring it up from the screen here. You could go through the sketching thing and outline it and then extrude the whole thing, but it's a lot easier just to do a bunch of rectangles. So we're going to sketch on this surface here. And go to a rectangle. And 0.25 by 3.6 dimension. 3.6. It's small, doesn't it? Here, 2.5. No. 0.25. Okay. Dimension 0.25. When you see me backing out of that, I'm just hitting the Control Z and it backs out one step at a time. And so if you make a mistake, that's a real quick way of getting out of it. Now, this one here, if I go back to my drawings, it's 59.5 millimeters long. So I want half of that. And if I get my pencil here, I'll quick figure that out. 59.5, 2, that's a 2, 975, 2970, is that right? 2, 19, that's a 9, carry a 1, 7, yep, and 5, yeah, 2975. So let's see, where are we here? We're going to extrude this 29.75. Check. I'll look at it just to make sure it looks good. That looks pretty reasonable. Right. I wish it wouldn't change the zoom factor, but it does. And so we have another rectangle here. Sketch. There. This. And this one, if you take, see where we were here. That's 0.8 by 1.5. Dimension 0.8. And 1.5. Okay, just leave it where it is. There. Check. Extrude this. What did I say? It was 29.75. Check. And we have one more rectangle to make. Sketch on this surface here. This is the main. Oh, come here. This is the main plate. Oh, I hate when I push the wrong button. Okay, dimension. There we are. 0.4. And this one here is 5.25. Oh, pretty close. And we check this. And we extrude this. 29.75. Okay, check. So now we start building our floor beams. And we go to part 4. And we'll translate it. Liner points from midpoint to midpoint. I'm happy with that. And line, and we'll take part 5. Okay. And we'll translate liner points from midpoint to midpoint. Check. Now take part 4. Yeah, 4. And we will translate liner points from midpoint to midpoint. Copy. Check. And we'll take part, which one is it? 4? 3. Part 3. Translate liner points from midpoint to midpoint. Copy. Check. Okay, the floor beam is built. Now we got to position it. And there's going to be 1, 2, 3, 4, 5 of them along here. So if I go down here, I'm sort of curious about this line here. Measure. .2 millimeters. Okay, that's good. So what we're going to do, take this floor beam, and we're going to translate the, well, oops, wait a minute. Take the whole thing, make it one piece. So I'm just going to be moving one part at a time. Check. I'm going to translate it. Part 3. Yes, part 3. Right. Translate. Line of points from that center point there. So we get a line on this thing, angle on so I can see it, to center point there. Boom. Check. The computer crash in the middle of the presentation didn't help much. I did find a couple of corrupted system files that I corrected. That may have been the problem, but I was running the graphics processor pretty hard and it may have overheated. I'll be monitoring the GPU temperature while using Onshape to see if that's a potential problem. It was pretty obvious while doing this drawing on the show that I messed up. I used the cross-sectional dimensions for the stringer rather than the floor beam. Mistakes are unavoidable. Even if you don't make a mistake, you often want to change the design. In both cases, when working in a history-based system like Onshape, you back up through the history until you reach a point where you can move forward again with the changes. Rather than going back so far that the incorrect floor beam is deleted, we can use that geometry by simply rotating it 90 degrees and moving it out of the way for the correctly dimensioned floor beam. Now we'll build a correctly dimensioned floor beam. The floor beam is installed and the triangular stiffener is moved into place. And now they're joined together to form a single component. With those two parts joined, we can now make an array of them. The panels are 14 millimeters wide and they are installed on every third panel. Now using the thicken command, lengthen the stringer to 175 millimeters total length. To position the stringer, we first center it on the center floor beam and then move it to its proper position. Finally, join the whole assembly and mirror it to finish this stage of construction. Next week, we'll finish this project with the upper and lower cross braces.